Hello and welcome to this presentation on A-level chemistry at Wigan and Leigh College. What is chemistry? Well, chemistry is the study of the world around us. We can split it up into three different sections that you're probably familiar with from GCSE, which are inorganic, physical and organic, and to a lesser extent organic chemistry. Okay. So the inorganic is the topic you're most familiar with. That's the study of the periodic table. What are those trends in the periodic table? What reactions occur? And we can apply that to things such as uh, what materials do we need to take a rocket up into space. The physical side is about how much do you need to put into a reaction, what energy are you going to get out of reaction. So how much energy do you need to get a rocket into space, how much fuel do you need to put in these rocket boosters. So that's very, very important. Also, the organic section. This is something you will not have studied very much of at GCSE. You've studied alkanes, and what we'll do at A level is explode this world of organic into something new. I'm very fascinated, and then we can relate it to things such as the design of new medicines. So some of the first year topics you will encounter: energetics, so things called enthalpy changes. You'll be familiar with exothermic endothermic reactions, and if you've been to one of our sampling days, you'll have seen the demonstration of the whoosh bottle. Redox reactions. Why is it that you can get these really funky coloured paints, or any colour paints? Well, it's to do with the different oxidation states of metal ions, and we'll be able to do some test tube reactions to see how these colours change. The periodic table will take what you know already from GCSE and look at the periodic table in much greater detail. So for example, chlorine is put into swimming pools to make sure that we kill bacteria, so you don't get an infection when swimming. But what happens to that chlorine? How is it the chlorine is able to protect us? We'll look at applications like that, and also the organic chemistry. We'll look at different functional groups. So you will be familiar with alkanes, alkenes. We're going to look at alcohols, halogenoalkanes, and one of the functions of alcohols is in the food and drinks industry. And this picture here shows an industrial distillery. Okay, your second year topics. So we'll look at aromatic chemistry. Now, aromatic, you're probably familiar with the term regarding the scent or the smell of things. Aromatic chemistry is the study of benzene, which is a molecule you may have encountered, but one of the more important uses of aromatics and benzene derivatives was this thing here called TNT, or dynamite, which is trinitrotoluene, which was invented by Alfred Nobel. Okay. Look at things such as esters. Now, the smell of fruits, of flavorings, and again, especially if you put in artificial flavorings in sweets. So classically, pear drops will make the flavor in pear drops in the lab, and then we'll take the idea of redox reactions, we'll apply it to different scenarios, but one of them will be electrochemical cells. So why is it that your mobile phone, laptop, why is it that the battery on that works very well when you first get it, but after a couple of years it's not so good? Why is it that the battery in a phone that you'll buy in a couple of years time is better than this one? Okay. Your examinations, in the first year you'll have 2 AS exams. They're split up into some of the physical chemistry and inorganic chemistry, and then paper 2 is the remaining physical chemistry and organic chemistry. Once you progress into the second year and you study for the whole A level, then you have 3 exams. Papers 1 and 2 are split as above, so physical and organic for paper 1, physical organic for paper 2, and they cover topics from both years. And then finally, paper 3. Paper 3 looks at all topics, but there's a particular large emphasis on practical techniques, and that is something that's very important in the A-level science exams. And at the end of your exams, you will be given the practical endorsements on your certificate as well. Okay, trips and visits that we have. So we've organised for next year Liverpool University research laboratory tour. So you'll be able to see what happens in an actual research laboratory. So that'll be quite fascinating. We've had visits from Medical Mavericks in the past. We'll have them in again. This is a fantastic opportunity because if you're on the applied medical pathway, then you get to have a real taster of some of the apparatus and the techniques that are used in a medical setting. We've had visits from the medical detection dogs. Again, a fascinating world out there that not many people are aware of. And also, more kind of chemistry based, we'll have spectroscopy in a suitcase again. So we'll get in a special machine called an infrared spectrometer, and you'll be able to analyze different substances and get some very nice data out of it. Okay. Finally, the careers. What can you do with A-level chemistry? Okay. Right. Well, chemistry is regarded as a facilitating subject. So what this means is that all universities think it's a fantastic A-level to have, and you will be able to apply for virtually any course, and a university will say, brilliant, you can come onto our course. Chemistry A-level is a core for medicine, dentistry and veterinary science degrees, and also you can think of it, also one of the applications is getting into the pharmaceutical industry. So the research and development of new chemical entities. So these are the new drug molecules which in a few years' time people will take as pills. Also chemical engineering, again very, very important aspects of the world, used a lot in, say, the pharmaceutical industry, also in, say, the manufacturing of crude oil. It will be very, very important. In fact, it's even important in like the food production. So just thinking about how we get raw materials into making just a simple digestive biscuit. You know, a lot of that's to do with chemical engineering. And then finally, chemistry. Again, chemistry careers cover a wide range of areas. You know, from things like recycling to you know, the development of new batteries, the new paints, just to cover just some of them. Okay, thank you for listening.